Hello again, one last problem from the second projectiles web assignment for you. And there's a lot of parts to this one, but this is really a good problem because it builds upon the stuff that we did before and you do it one step at a time, so it really should help you learn this stuff. A high-powered Nerf-type dart launcher shoots at 15 meters per second. Neglect air resistance. One is fired at a 30-degree angle and with the horizontal. And for this particular one, I'm not going to do all the numbers at the end. I'm just going to kind of get you started for each part. They're not really numbered with or lettered either. But to get this horizontal component, that is the first one. This is kind of like the adjacent side to our triangle here. And we've got the hypotenuse. So which of these has adjacent and hypotenuse in it? Yes, indeed, it's cosine. So if you use the cosine function and solve for the adjacent side, that is the horizontal component. I'm going to let you do that. For this vertical part here, this line, this component, is directly across from or opposite our angle. So we're looking for this opposite side. We've got the hypotenuse. Now maybe we've even got this. We could resort to one of these trig functions, but maybe you even want to do the Pythagorean theorem. In either case, that's okay. You can do either one of them. So I will write out the trig function thing. So if you want to use sine, you can do that. Or you can do the Pythagorean theorem. And next, we want to get the time in the air. So like we've been doing, that has something to do with our acceleration from gravity. It also has to do with our vertical component there. So once we get this side here, this vertical component, we're probably going to use that with this equation. And you can approach this a couple of ways. You can think about it going all the way to the top, and you can get the time to the top, and then when you get that, you can double it. Or you could go all the way to the bottom, back to the bottom. But when you do that, you've got to think about it goes up with this speed, and then this final speed is whatever that is going down or negative. You can approach that either way. The horizontal distance the thing goes. Once again, which way does gravity act? Down. Does gravity act sideways? No. So sideways, we don't have any acceleration. We don't have to worry about any acceleration, so we can just do something like that. Now this v, though, can be a little bit confusing because we've got a speed there, and we've got a speed there, and we've got a speed there. We've got all these numbers flying around. So which one to use? Well, we were saying we're finding the sideways distance. No acceleration. So if we're using the sideways distance, we're going to use the sideways speed. This first one that we got here, with the adjacent side. So I'm going to rewrite this with a little h here and a little h there. So use our horizontal speed, the time that we got, and you can solve for that one. One more part. The maximum height that the thing reaches. This one's a little bit different than what we've done. It's still not too hard. This also relates to what we had been previously learning about. That spot there. That's what we want to get the height to. Now sometimes people want to say, oh, I've got this speed and I've got a time. The speed times the time will give me that distance. And that would be good if we were going at a nice constant speed, but we're not. We're accelerating as we go up. Gravity's pulling on you. I can't make that go away, so we got to do something with gravity. Well, this is a little bit complicated, a little bit longer, but we can definitely use that equation because we're looking for a distance. We've got our initial speed, and we've got the time. This is just the time to the top. If you found the whole time, you might have to divide that by 2. So we've got that and got that. Our acceleration, gravity. Same time, don't forget to divide it by 2, if you got the whole time. Put another check mark there. So we've got all the stuff we can put into there. If that's a little bit too much for you, if it's a little bit too tricky, you can kind of think about it a slightly different way. You can think about it as, what if we start here and then we just drop the object? We can still, once again, use that half of the time, and we can kind of just think about it from that point of view. You end up using the same equation, though. So, regardless of which of these web assignment problems you're working on, notice we've got diagrams, especially with vectors. We're writing down the equations we're using, even if it's some of this math stuff. We've got some units in here, not a lot for this particular one. I was really pretty lax with that because I didn't put all these numbers in for us. But make sure you show all your work. Otherwise, you're going to have to kind of redo it or revise it anyway. All right? So keep working on these. Do the best you can.